To lesson 2.1, we're going to describe location and distribution. We're going to introduce you to the normal distribution. You've heard about the bell-shaped curve, or that's a normal distribution. Good grief, that is our friend for the entire year. Unfortunately, we'll learn about it, and then we'll depart from it for a second, and then we'll come back and we'll approach it as probability. So at this point in time, we're going to look at the normal distribution, and we're just going to look at that as percentiles, or a location within a distribution. As we progress and we learn more about probability, we're going to express these areas and percentiles that we find as a probability of a certain event occurring. But let's start simply. Yeah, we're going to do all that stuff. It's going to be cool. All right. So if you're looking at a percentile, right, it is the value of observation, or the percentage of value of observations less than that. I don't know why I just want to say the word value. So if you wanted to know what Jenny's percentile is, and she got an 86, right? That's on this stem plot. That's going to correspond to this one, right? This is the 86. So in the red, we've counted up the number of values that are strictly below it. Be careful. Most common mistake that people make when finding a percentile is they include the value. Like, so they would include 86 and then get an incorrect count of 22, right? So there are 21 below. But if you were to include the value 86, you would get the wrong answer, right? So be careful with that. It's strictly below. When you're looking at a percentile, you have a value, and you're only looking at the percentage of values below it, not including it, okay? All right. We can also represent the location of a observation in a distribution using a graph that's called a cumulative relative frequency graph. I am going to call it, that's hard to say. It has another name. It's called an ogive. So this is also called an ogive. That's what I'm going to call it. So it is a relative cumulative frequency graph. Call it an ogive because actually it's the name comes from a certain type of arch in architecture. That style of arch is called an ogive, and so they realized that this graph looked like that arch and called it that. Not that that's important to know, but it's fun. We're going to get some practice with an ogive here in a little bit. That just tells you where things are. So, like for instance, with this particular ogive, if I wanted to know what the first quartile is, I can find that information from this ogive, right? And the reason why is because my y-axis is the percentile, right? Quartile 1 is at the 25th percentile, right? So I can go across and I can go, okay, where is 25? Oh, so 30 is maybe about there. So maybe 25, that's probably not about right. Let's do better. Oh, I did the same thing. I want it to be really centered. Okay. So that would mean that I would go to 25, and then I would match that value. So my lines are probably off. It's probably about 50, right? So I could say that the quartile 1 is 50. It's at the 25th percentile. You go over, that's where the 25th percentile is, and you'll find that. We're going to do a bunch of examples with that. Just wanted to show you what it's useful for. Like, what if I wanted to find the median? All right, I go to, this would be 50%, right? That's median is at your 50th percentile. And then I would go down and see where that matches on the x-axis. I don't know, 57, something like that. We'll make estimates with these if we don't have exact values. So the median would be 57. It's the way you use an ogive. I won't make you make them. I have in the past. I didn't think it was a good exercise because the chances of you seeing one of these on the AP exam are slim. There'll probably be one in a multiple choice section, but I can't recall seeing one on a free response. So I'm sure there is one at some point, but you don't have to make it. You just have to read it. All you have to be able to do for the AP exam is be able to read this and interpret some values. All right, this thing is going to be coming up all the time. I always feel like it's weird that we do this and then we go into bivariate data. We look at scatter plots and stuff. And then after that, we do experimental design. And then the next unit is probability, and then this comes back. So it's kind of weird. We'll get acquainted with it for now, and then we'll really get deep into it as we go on. This tells us a location in a distribution. Our z-score tells us how many standard deviations above or below the mean a particular value in the data set is. So, for instance, if I calculate the x value, I subtract the mean and divide by standard deviation, and I get 1. That means that that particular x value, that particular observation in the data set, was 1 standard deviation above the mean. And we'll do an example. Don't worry about this example. We'll do a bunch of these. We also call this a standardized value. And we'll get what that means because it corresponds to the standard normal distribution, which tells us how many, it gives us standard deviations from the mean. And I'll draw a picture of that here in a little bit. Okay, this is going to come up also a lot during this year. It kind of gets smattered in, if you will. Just the idea that if we transform data, what happens to our measures of center and spread? It's important to realize that if we're going to add or subtract, right? Think about that. The measure, if you're going to add or subtract something to every data point in your distribution, right? So say you were off by 5 or something like that. You realize you measured wrong, right? And you need to add 5 inches to everything, right? What's going to happen is your mean is going to shift up by whatever you're adding everything to, right? And we're talking about adding something to every value in your data set, not just one. So that's going to add or subtract depending on what you're doing, right? But if you're adding and subtracting, think about that. Think about if the mean went up, right? The mean goes up. What would happen to measures of spread? They're not going to change, right? The width won't change. The location will, right? So if you add something, right, and your median shifts up, your measures of spread are going to shift up, but the actual interval will not change. And we'll play with that a little bit, right? So, right, your interval will shift up, but that value doesn't change. And that's the point of this. All right, so we also need to figure out, oh, well, this is an example. I'm going to do an example of this for you. All right, so also you can transform data by multiplying. It says or dividing, but if you're going to transform data, I recommend always multiplying. Multiplying by a fraction is the same thing as dividing. So I try to keep it close to multiplication. If we're going to divide, I'm going to multiply through by a fraction, right? Right. If you're going to divide it by 3, just multiply everything by 1/3, right? What is that going to do? It is actually going to change both your measures of center and your measures of spread, okay? But will not change the shape of the distribution. All right. We'll get into examples where you would multiply. Hey guys, we did it. All that stuff. All right, let's get ready to do some examples. So keep an eye out for that video. We're looking for the 2.1 examples. I'll do that for you guys. Thanks so much for watching. I hope you have a fantastic day. And if you're not, I bet it's going to get better. Bye. Don't forget to smash like.